Alright, I think I'm recording. Hello Algebra 2 students. We have, in that first week of school, we began looking at skill packet 5, which is polynomials. The long division is very challenging for us. We quickly moved on to a method that is referred to as synthetic division. It's not quite as powerful as long division because it only works in limited cases. If your denominator had an x squared, or if even there's a number in front of the x, you're going to have to do long division. But for synthetic division, it was much easier. We saw the patterns more clearly and had much more success. The skill 5C, we just started it the other day, and it's going to be a little bit of a challenge because it really is going to rely on our ability to factor. And some people have excellent factoring skills, and well, it's not maybe their favorite thing to do. So we had a homework number 3, and that's what I'd like to go over and stuff. Like I say, you did very well in the synthetic division, and I have posted a solution. Now, wait a second, let me pause this while I go find it. Well, I'm back. I had some things that I did not have set up correctly, and rather than having you guys watch me move the mouse around and stuff while I paused the video and took care of that stuff. Alright, so I want to talk about our solutions to homework 3. For the most part, everybody did excellent, especially on the first 6 problems. With the synthetic division, you did very well. Now, when you log in to Edline, I believe there's a link that will take you directly to the Algebra 2 page. You can see that tutoring started today. Tutoring after school is on Tuesdays and Thursdays. Mrs. Sparks sent out information to the math teachers about requesting tutors, and also pointing out that if students need help, that they can receive help in the Media Center after school on Tuesdays and Thursdays. On the right hand side, underneath the assignments, you can see that I've created a folder that says keys and selected solutions to assignments. So if we click on that folder, right here is the solutions to homework 3. They are handwritten, and I scanned them in from our copy machine and made a PDF file and posted it on there. Well, I'd like to go through and talk about how I got my answers. So in problem number 1, I cut and pasted this from our typed homework assignment, and let's take a look at how I solved this. So the first thing that I want to look for is in my numerator, and even though this is not written as a fraction, this first factor here is considered the numerator divided by the denominator. So it's not written in fraction form. When I look at the numerator, I need it to be in descending order. Take a look at the exponents, 3, 2, and when something's not written, a 1 is implied, so it goes 3, 2, 1, and the constant. To use synthetic division, you must have a coefficient of 1, and the exponent on the variable must be 1. So this is set up fantastic to do synthetic division. Let's start with the denominator here, the x minus 1. You always take the opposite of this number. The opposite of negative 1 is positive 1, and they suggest that we draw and put it either in some type of a box, or sometimes you'll see an L shape around it. You want to make some kind of marking so that you're able to quickly and easily identify that as we're doing this problem. So right next to it, I wrote a series of numbers, and you have to think, how did I get these numbers? Well, I looked up at the numerator, and I used the coefficients. I had a 1x cubed, so I just pulled the 1 down. I had a 3x squared, I just pulled the 3 down. I had a negative 1x, I just pulled the negative 1, and I had a constant of negative 3. And we see in a later problem, if there's any terms that are missing, we may have to write that we have 0x squared, so that we have 0 x's to get things to line up right. Alright, so we begin with this first value that's to the right of the box, and we're going to bring it down we're going to create some spacing. Let's do this. We will temporarily erase our answer. Alright. So our first step is always, in all of these problems, is to simply bring this number straight down. Nothing happens to it. Don't change it. It's exactly as is. And that's that leading coefficient. That's that 1 from the numerator. Alright. If any numbers that we write below this line will eventually end up getting multiplied by this number in the box. And there's a pattern. So I take this positive 1 that's in the box, I multiply it times the 1 that's underneath here, and I write the result below this next number. Well, it's pretty easy to see that 1 times 1 is 1. So if I erase that, hey, I've got a 1. Now, it's different in long division. You subtract, but in this synthetic division, we're going to add these values. 3 plus 1, hey, that's 4. Okay. Well, as we said, if you're a number that's below the line, you're going to get multiplied by this number over here in the box. Let me erase these arrows because now my attention is on this 4. So I take this 1 times the 4 and I write the result underneath the next number. 1 times 4 is 4, so we write a 4 right underneath this negative 1, and we add these two numbers together. Negative 1 plus 4 should be a positive 3, and it is. Okay, so we're doing the same thing now. This is a number below the line. If you're a number below the line, you multiply the number in the box. So this 1 times 3, and we write that result directly underneath our last value here. When we add these numbers together, they cancel each other out. So now we have these numbers that are going to help us write our final answer. We have to try and determine what these numbers mean and how we're going to write our answer. This last number is always the remainder. Okay, that's always going to be the numerator, to where I'm going to put that value in the numerator and this x minus 1 in a denominator. So you're going to see right here that I have my remainder. When that remainder is 0, technically I can get away without writing that. But it's a fantastic habit to go ahead and write that 0 there, because later on when they give me a problem that the remainder is not 0, I'll be in the habit of writing that fraction. Well, now I have to move on to the 3 here. So you'll notice I'm actually, we normally write and read from left to right, but I'm working on the right and moving towards the left. So this was my remainder. That 3 is my constant. So I write the 3 down without any variable after it. Okay. The first variable is going to be after this 4, and this is going to be 4 times x. And then as I move to the left, this is 1, so it's going to be 1x squared. Now, I could have started on the left and wrote 1x squared plus 4x plus 3 plus 0 over x minus 1. If I recognize the degree of the numerator is 3, the degree of the denominator is 1, 3 minus 1 is 2, I know my answer is going to begin with x squared. So I use that coefficient. So they asked me to take this numerator, divide it by x minus 1, and here's the result. Alright. So again, I have another division problem, and it's set up perfect for synthetic division because I have a coefficient of 1 and I have an exponent of 1 in my divisor. When I look at my numerator, and sometimes they'll refer to that as the dividend, I see that this is in descending order. I have cube, 3, 2, 1, and the constant. So it's written perfect for me to do my synthetic division. You can do long division, but if the directions say synthetic, you must follow the directions. Alright, so let's take a look at what I did. Hopefully you can read my handwritten solutions. First, I just simply copied the problem down. And as I'm copying it down, I'm thinking those things. Is it in descending order? Is my leading coefficient a 1? Is the exponent a 1? Am I able to do this with synthetic division, or do I have to go back and do long division? So I start with the denominator. That's where I started with problem number 1, and I take the opposite of this value. This is a -2, so I'm going to write a +2, and I'm going to write it in my box. Then I'm going to come in and take off what they call the coefficients in front of my variables and my constant term. So you can see I took the opposite of -2. I put that number in a box. I want to draw my attention to that because I use that box a lot to get the rest of the numbers in my solution. I'm always multiplying by this number in the box. Now, just like last time, oh, hey, you know what? Let's white out our answers. Yep, it's not going to let me. Alright, I'll go like this. Hey, so I paused the video and then whited it out. So I can use this eraser. This 1, it comes straight down. And we write that 1 below our line. So, well, there it is. I have a 1 there. Now, any number that I place below this line is going to get multiplied by this number in the box. So 2 times 1, and I write that 2 underneath the next number. So right below this -4 is a 2, and I add these values together. -4 plus a +2, my answer is going to be negative, and I get a -2. Well, I don't know why that's being difficult to erase. There we go. Okay, so I have a number that's below the line. I multiply the number in the box times -2. I then come over. So you kind of see this check mark. You see how it went. Let's change colors here. Don't laugh at me. This comes down, multiplies that number, and it's written right next to it. Then I can draw an arrow. I multiply it by this number, and I write it right next to it. So I think of this as like a check mark. This pattern here. This goes there, and I just do it as I move from left to right to each number. Whatever kind of pattern helps you to recognize how to get these numbers that I'm writing right below the numbers that I had from my coefficients. So a +2 times a -2 gives me a -4. I write that below the 6. And I was going to say, if that's my solution, there's a sign error. The negative sign is there. It's just being difficult to erase. There it is. Okay. Add these together. 6 plus a -4 is a +2. So that number's below the line. 2 times 2 is 4. I write the 4 underneath here, and then I add these together. And again, I get a remainder of 0 like we did last time. Okay. Now, this 1 right here is going to be multiplied x times, and I have to figure out what that exponent on x is going to be. Well, I take the biggest degree of the numerator, or the degree of the numerator, minus the degree of the denominator. 3 minus 1 is 2. So you're going to see that I start this out as 1x squared. So then it's going to be minus 2x, then plus 2, and then plus my remainder. I don't know why that Xerox that line. See that line that's cutting through there? Didn't get a very good copy. Alright, but anyway, that is our final answer. We did this division with synthetic division. You may see division problems written like this horizontally with this division symbol, the bar and the dot above and below, or you may see a division problem simply written as a fraction. Okay, like I say, they wanted us to perform that division. We chose the directions told us to do it using synthetic division. We did that up here. We showed our work, and here's our final answer. All right, so number 3, it's beginning to feel a little bit like Pete repeat, that if we're understanding the ideas of how to do these, and we really have a system down packed, is just applying that system over and over again to each new problem and being very careful with our arithmetic and be very careful and not to make any sign errors. Alright, so let's take a look at this. Alright, I try to begin in a consistent way each time, and that's I take a look at this numerator and I determine, is it in descending order, and do I have any missing terms? If I do, I'll have to have, if I were missing an x, I'd have a 0x there. If I were missing an x squared term, I'd write a 0 there. Alright, so, oh boy, that's awful thick. I have my exponents in descending order, 3, 2, 1, and the constant. My divisor, my denominator, has a coefficient of 1 and an exponent of 1. Had that been anything different than a coefficient of 1, had that exponent been larger, I would not be able to do synthetic division. But it's set up nice for synthetic division. So we look at the denominator, and if you recall, we had a -2 here, but we wrote +2 in the box. Remember, we write the opposite. So if this is a +4, then over here in the box you're going to see a -4, and you're going to see numbers written right next to it. Where am I getting those numbers? They're coefficients right up above here, a 1, a -7, a -7, and a 20. I don't write the variables down. So let's take a look at this. And you see that that's exactly what I said I would do. The +4 is -4, and those are the coefficients. Now, let's move this down. Alright. The first value, in this case it's a 1, whatever it's going to be, it's always that number. It comes straight down, and we write that number below the box. You do not multiply times the number in the box until you're below that line. Alright, so that number is below the line. -4 times a +1 is a -4. We write it right underneath the next number. We add these values together, and -7 plus a -4 is a -11. The number's below the line, so it gets multiplied by the number in the box. Negative times a negative is positive. 4 times 11 is 44. And at this point during class, if you remember, people are like, boy, I'm getting big numbers. I haven't got that before. Am I doing anything wrong? No, just stick to the pattern. Be careful with your arithmetic, and I think that you'll be fine. So the -4 times a -11, negative times negative is positive. We got the 44. If we add these guys together, we get +37. That's a number below the line. It gets multiplied by the number in the box. A -4 times a +37, use a calculator, and I get -148. If I add these two numbers together, I get a -128. Okay, so that's not my final answer, but I'm one step from my final answer. I use these numbers to easily get my final answer. So they gave me a division problem, and I usually write it over here on the left hand side. And then I write our symbol for equality, meaning that this fraction, this division, is equal to, and I have my answer. Well, once again, I need to look at the degree of the numerator, look at the degree of the denominator, and this 1, I need to figure out, well, I know it's going to be 1 times x, but what's the exponent going to be? Is it going to be a 1 times x, a 1 times x squared, a 1 times x to the third, a 1 times x to the fourth? What's it going to be? Well, if I subtract the degree of the numerator minus the degree of the denominator, 3 minus 1 is 2, so I know I'm going to have 1x squared. So as I move this to the left, there it is, 1x squared. So then that makes the other ones easy because it's in descending order. You count down. This minus 11 is going to get multiplied by x to the first. And we typically don't write x to the first power, but you can if you'd like to. Then we have a +37, so we use a plus sign, and we write +37. And then we have this number before that was 0, but remember I said, hey, get in the habit, that's your remainder of writing that in the numerator. Now, with that being a negative, what I always do is I add my remainder. So I always put a plus here, and if this answer is negative, I put it in the numerator as negative 128. I have noticed that a few students are making sign errors, that you're seeing that negative sign, but you're writing it twice. You're double counting it, because you're writing a minus sign here, and then you're writing a minus sign up there. Those double negatives turn to positive. That's incorrect. You're not going to get full credit if you do that. Always make this plus a remainder, and let the numerator, if the number's negative, then the numerator's negative. If this number's positive, the numerator's positive. Sometimes you add positive values, sometimes you add negative values. So there's our answer for number 3. So 4, 5, and 6 are done in the same way. Now you can skip on this video. The default is to prevent skipping, but you can move that bar and fast forward to problems if you want to look at some of the later problems in this. But let's go ahead and finish these problems before we do solving our equations. Again, I have a numerator, and it's in standard form in descending order. The exponents, 3, 2, a 1 is not written, but it's implied there. 3, 2, 1, and my constant number. The divisor, my denominator, has a coefficient of 1 and an exponent of 1. I'm able to do synthetic division. Had this 1 been some number like 2 or 3, I would have had to use long division. Had this exponent, had that been an exponent of a 2 or a 3 or something different than 1, I would have had to have used long division. But we're able to use synthetic division. So we look at this, our first step was to make sure it was in descending order. Second step was to make sure that we had the correct divisor. My third step, when I jump in to start my work, is I focus my attention on that minus 5. I need the opposite of that, so I put a plus 5 in the box. Alright, so I'm going to put a plus 5 in the box, and I peel off the coefficients. 1, negative 3, negative 5, negative 25. I give myself some space underneath this line of numbers, and I draw a line there. And always my first number, whether it's a 1 or something different, whatever that coefficient is, that number comes straight down. So you'll see that I have a 1 written below that line. If the number's below the line, it will eventually get multiplied by this number in the box. 1 times 5 is 5, negative 3 plus I add the columns together, and I get a 2. That's below the line. 5 times 2 is 10. I write the 10 underneath the next number. I add these together, I get a 5. 5 times 5 is positive 25. When these cancel each other out, they're equal and opposite. This is negative 25 and positive 25. So I know that this is going to be 1x times some number, but until I look at the degree of the numerator and the degree of the denominator, I may not be able to figure out what it is. Well, we can figure it out, but 3 minus 1 is 2, so this is going to start out 1x squared. And from there, I think you're fine, because you'll have 1x squared plus 2x plus 5 plus your remainder, and it's always plus the remainder. That remainder is in the numerator. Since it's 0, you could further reduce this. 0 divided by x minus 5 is nothing. So you will have students in classes, and they are correct, write their final answer without that fraction there. I claim that you could argue that you're adding 0, which doesn't change the number, and that you've developed a good habit of writing your remainder in the numerator. And notice here, this denominator, let's change colors here. This denominator is the same, okay? The denominator never changes through your problem. Alright. Now this problem, I gave you a hint right below there. Remember that in the previous, my first steps was to look to see, am I in descending order? Are the exponents counting down? But I'm also concerned that I have an x cubed. I don't have an x squared. I don't have an x. It goes from x cubed to 3. So I need to rewrite that. And I put that directly on your homework. I didn't want people to make a mistake. Now in the future, you won't see that hint written there. You'll have to recognize to rewrite x cubed plus 3 as x cubed plus 0x squared plus 0x plus 3. Alright, so it's in descending order. I know I can use synthetic division because I have a coefficient of 1 and an exponent of 1 in my denominator. I start here with that minus 1. The opposite of negative 1 is positive 1. I have nothing underneath there. It's on my next slide. Alright, so this is my handwritten solution that is posted on the website, Northview's website. I'm not in the habit of always making these videos. It's very strange to be talking in an empty room into a microphone, solving this totally by myself. So sometimes if I get laughing or if I stumble, it's just because of the awkwardness it is doing this problem out loud when you're the only person in the room. Alright, so let's look at negative 1 and write a positive 1 in the box. The 1, 0, 0, 3. I need those zeros there. I write it right after the box. I give myself a little bit of room. I draw a line. The first number always comes straight down. If you're a number below the line, you get multiplied by the number in the box. 1 times 1 is 1. We write it underneath the next number. We add these together. 0 plus 1 is 1. Hey, 1 times 1, we have another 1. We add these together. 1 times 1 is 1. We add these together. Now this time we don't have a remainder of 0. So we've got a 1x, but I have to figure out, is it 1x squared, 1x cubed? What's the exponent going to be? Well, I could always work from right to left. This is the remainder. This is the constant. This is x to the first power. This is x to the second power. Or I can come in and say 3 minus 1 is 2 and just start off that this is 1x squared plus 1x plus 1 plus my remainder plus 4 divided by x minus 1. So you see that's what I have written. Alright, let's move on. Hey, this time there's no missing terms. My numerator is in descending order. The exponents are 3, 2, 1, and then a constant. My denominator is set up perfect for synthetic division. There's a coefficient of 1 and an exponent of 1. Alright, so we focus our attention on that positive 3, take the opposite of it, and that's the number in the box. That's a positive 3. The opposite of positive 3 is a negative 3. So you see that I have negative 3 in the box. You also see that I have a leading coefficient here of 3, and it goes 3, 17, 21, and negative 9, and I write those numbers down. Now, in our previous problems, there was a 1 there, but I mentioned many times, whatever that number is, it goes straight down to, we write it below the line, so you'll see that I have a 3 there. If we have a number written below this line, we know we're going to multiply it by the number in the box. Negative 3 times positive 3 is negative 9. We add these together. We get an 8. Negative 3 times the positive 8 is a negative 24. We add these together and get a negative 3. Negative times negative is positive. Add these together. Hey, we get another 0 remainder. Alright, so I could say this is the remainder. That's the constant term. That's x to the first. That's x to the second. Or I could come in, look at this degree of 3, look at this degree of 1, the degree of the numerator minus the degree of the denominator. 3 minus 1 is 2. This is going to start out 3x squared. Then it's going to go plus 8x minus 3 plus 0 divided by x plus 3, my remainder. Alright, so there you have it. let's take a look at our factoring now. See if I can find something. Well, I can't. So I went to the website and pulled up our note packet, and I have typed in 4 steps that are going to help us to solve polynomial equations. However, on this homework, our first 2 steps have been done for us. But step 2 is going to be the most difficult. That's the most challenging. There's where you have to factor problems, and so you have to develop factoring skills. So let's see. Let's go back to, there we go. All right, so my first 2 steps have been done for me. They factored it, and I now want to set each individual factor equal to 0 and solve. So that's what I did. This 2x minus 1, I write 2x minus 1 equals 0. Or x minus 5 equals 0. And you think about it, and that makes sense, because what's all this 2x minus 1 is some number. Okay? Right now, I don't know what that number is. But I know when I multiply it by this other number, I get 0. So hey, when I remove this box, it might be equal 0. So the 2x minus 1, since it might represent 0, I take that expression, set it equal to 0. And the same thing over here. I've got this 2x minus 1 times some number is 0. Well, hey, one of these factors has to be 0, so maybe it's what's underneath here. I remove it. Nah, it doesn't look like 0, but it does represent it. So I set x minus 5 equal to 0, or I should say it could represent it. So on the left-hand side, we have a 2-step equation. In 2 steps, we'll be able to get our answer. So we want to get the x by itself. The opposite of subtracting 1 is to add 1, so I added 1 to both sides. Now, it's perfectly fine, and maybe it's even good for you guys to write plus 1 and plus 1 underneath there. Alright, so these cancel, and that's how I was able to just have 2x on the left, and of course 0 plus 1 is 1. Well, I don't have the x by itself yet. Right now I have multiplication, 2 times x. The inverse operation of multiplication is division. I need to cancel that 2, so I divide both sides of my equation by 2. When you divide by 2, 2 divided by 2 is 1. Hey, you just have the x. And on the right hand side, if you divide it by 2, that's how I got x equal to 1/2. So in writing this out, I didn't write down all my chicken scratches, but you can come in and write those, or you can come in and think about it. I have clearly illustrated the next equation, then the next equation, and you can figure out what I did to get to the new equation. So I have 2 terms here. I want to get the x term by itself. The inverse operation of subtracting 5 is to add 5 to both sides of the equation. If I add 5 on the left-hand side, those terms cancel, and I just have x. And on the right-hand side, 0 plus 5 is 5. So those are my 2 solutions for number 1. So let's move on to the next one. Alright, so here I have 3 factors. And again, I come in and say that they've done the steps 1 and 2 for me. They've looked at it, they've taken something and they've written it in descending order. They've either used an X method or a factoring, some type of factoring skills to write this expression as the multiplication of 3 values. So if this multiplication is equal to 0, we have that zero product theorem that says one or more of the factors has to equal 0. So if x minus 3 could equal 0, 3x plus 1 could equal 0, or x plus 1 could equal 0. Well, the first equation and last equation are just one step and you have the answer. Add 3, you've got your answer. Subtract 1, you're going to have your answer. This middle equation requires 2 steps. You subtract 1 from both sides and then divide by 3. So there you have it. Subtract 1, divide by 3. And sometimes you'll see people write the solutions as a set. You'll see these curly braces. These are the numbers that if you come into our original equation and you replace x with this number, you'd have 3 minus 3, you'd have 3 times 3 plus 1, you'd have 3 plus 1. Since this 3 minus 3 is 0, it doesn't matter that this is 10. It doesn't matter that this is 4 and that 10 times 4 is 40, because 0 times 40 is 0. Alright. We have 3 factors again. So they've factored it for us. We take each individual factor, we set it equal to 0 and solve. The first one here is a two-step equation. Subtract 1 and divide by 2. These others are just one step and you have your answer. So I suspect that you're really good at that because you've had a lot of practice. If you do make a mistake, I suspect it'll be a sign error, or sometimes people accidentally divide the wrong number. They'll divide both sides by -1. You have to divide both sides by the number in front of x, so you have to divide both sides by 2. But sometimes you'll see people make mistakes like that, and then later they can look at it and figure it out. Alright, and again, this is the solution set. They write these curly braces to indicate that it's a set, that it's a collection of objects. In this case, a collection of numbers. Those numbers satisfy the original equation. Alright, so we have 3 factors again. The product of these 3 factors equals 0. They have done the factoring for us, and they have factored it completely. X squared plus 1 cannot be factored any further. X squared minus 1 could have been, but x squared plus 1, I can't factor that any further. So I come in and set each individual factor equal to 0. I create 3 equations. From this one equation, I create 3 equations. So the first one, x equals 0, is the easiest one. It's solved immediately as soon as we say, hey, if that's a number, it could be 0, and 0 times anything is 0. 5x minus 2 is 2 steps. To figure out what x is, we'll have to add 2 and divide by 5. So see, x could be multiple different values to satisfy the equation. 0 clearly satisfies the equation. 2/5 satisfies the equation. But this x squared plus 1, remember we were saying that one of these factors has to be 0, but how can it be x squared plus 1? For any value of x that you pick, whether it's positive or negative or 0, when you square it, it's never going to be negative. So in order to satisfy this equation, x squared would have to be a -1, because -1 and +1 give you 0. So subtract 1 from both sides, x squared equals -1. There is no real solution. That's how complex numbers, and that the square root of -1 is defined to equal I, and we may look at that in a later skill packet. Alright, so we've got 2 more problems. I know that it's getting a little bit late. Remember, you can fast forward if you need to. Boy, I've got 4 factors here. Okay, they've done the hard work for me. They've given it to it in factored form, but I'm now going to have 4 equations to solve. The first 3 are pretty easy to solve. This last one here, x squared, is more complicated because x equals 0 already is solved. I don't have any further steps. The x plus 2, x minus 2 are one-step equations. Now here, I'm going to do it one way and then show you a second way to solve the same equation. We don't have an x term, so one thing we could do is get the x squared by itself. Add 4 to both sides of the equation, divide both sides of the equation by 3, and we have x squared is equal to 4/3. Well, when we take the square root of both sides, we have to introduce a plus or minus symbol. And also, 4/3, we have a fraction underneath a radical. They don't like us. It's against the rules of algebra to have a number in the denominator underneath a radical. So I'm going to be clever and take this 4/3 and multiply it by the number 1. And I'm going to write 1 as 3 divided by 3. Well, the reason for that is that we can come in, we have properties of square roots that say if you have 2 numbers that are being multiplied together, you can take the square roots of the number individually and then multiply them. So this square root, this numerator, 4 times 3. How did I get a 2 right there? I split up the 4 times 3 into the square root of 4 and the square root of 3. 3 is a prime number. I can't simplify that square root of 3, but hey, the square root of 4, well, 2 times 2 is 4, so the square root of 4 is 2. Let's look at that denominator. How did I get a 3 down there? Well, look here, the reason I multiplied by 3 over 3 was to get a 9 in that denominator. When you multiply fractions, you multiply straight across, and I have the square root of 9, and the square root of 9 is 3. So don't forget the plus minus symbol. Rationalize your denominators. Let's solve this other equation a second way. Let's use the quadratic formula. Okay, so we need to rewrite this 3x squared minus 4 equals 0. And we wrote it in our standard form to identify a, b, and c from the quadratic formula. A is 3, b is 0, c is negative 4. I gave you the quadratic formula on today's homework, the homework number 4, on the front page. You do want to memorize that. You're not always going to have that given to you. Alright, identify a, b, and c, and now it's a matter of substitution. This says take the opposite of b. Well, the opposite of 0 is 0. Plus or minus the square root of b squared, 0 squared. Hey, so far the arithmetic is easy. Minus 4 times a times c. A is 3, c is negative 4. So we've got the 0 that we can forget about, and negative 4 times positive 3 times the negative 4. Oh, I've skipped a step there for you. Negative times negative is positive, and I have 4 times 3 times 4, 48. Okay. Now the denominator, 2 times 3, hey, that's 6. Can I simplify this radical 48? Is there a perfect square that divides 48? You know, I can come in with a calculator and take 48 and divide it by my perfect squares. Well, 1 squared is 1. That's never going to be helpful. 48 divided by 4, hey, that's helpful. I can take the square root of 4, but is there a bigger value that divides it? See, I want just not only a perfect square, but the biggest perfect square. Well, 3 squared is 9. The next perfect square is 9, and I get a decimal number. You know, so no, that's not. And I have my decimal numbers to round to 1 decimal, so I'll change this to a float. Well, so let me change that to a float for just a second to illustrate. That it is a decimal number. Well, so if I take 48, 4 squared is 16, and look there. Hey, 16 divides. So I can rewrite this 48 as the square root of 16 times the square root of 3. And I know I can simplify the square root of 16. That square root of 16 is 4. Now, the plus or minus came from when you're solving a quadratic equation, or no, it just came from the formula, the plus or minus there. Alright, 4 and 6 are both even numbers. I can take 4 divided by 2 and also take 6 divided by 2, and I have plus or minus 2 times radical 3 over 3, which is the same thing I have over here, plus or minus 2 times radical 3 over 3. So if you're able to solve for the x and rationalize the denominator, go ahead and do that. If you prefer to use the quadratic formula, identify a, b, and c, substitute, and then slowly simplify your answer, you should get the same thing. Alright, last problem. So hooray! We've got 3 factors, and if you multiply these 3 numbers together, this equation is claiming that you'll get 0. So what we're going to do is take each individual factor and make an equation of it. Take 2x minus 1, set it equal to 0. Take x squared plus 3, set it equal to 0. Take 2x squared minus 5, set it equal to 0. So this first equation is a 2-step equation. Add 1 and divide by 2. So I get 1/2. In this middle equation, when I subtract 3, look here, x squared equaling a negative number. When you multiply a real number times itself, how can it be negative? Negative times negative is positive. Positive times positive. The only way to get it is if you have equal and opposite number, or not equal and opposite value signs, a positive and a negative. But if you're multiplying it by itself, in the set of real numbers, we have no such number. Now, when they invented complex numbers, they defined the square root of -1 to be I, and we may look at that in a later skill packet, and you'll definitely look at it later if you ever have another math class. All right, so over here, this is one that we could use the quadratic formula, or we can add 5, divide by 2, take the square root of both sides, don't forget your plus or minus, and rationalize the denominator. All right, so this 2x squared minus 5, let me do that real quick with the quadratic formula. 2x squared plus 0x minus 5 is how I would rewrite it. Just to identify that b, let's make sure I copied that right, minus 5, yes. So I have that a is equal to 2, I have that b is equal to 0, and I have that c is -5. So the quadratic formula tells me to create a fraction. In the numerator, you have two terms separated by this plus or minus symbol. The first term is the opposite of b. Well, the opposite of 0 is 0. Plus or minus, and we have this radical symbol, this square root. Underneath here, we have a subtraction problem. The first number is b squared. Well, again, 0 times 0, hey, that's a 0. Minus, there's a 4 there, and then we plug in the number a. Now be careful here, my a and my 2 look a lot alike, but this is the number 2. And then 4 times a times c, c is -5. The denominator, remember this answer was a fraction, that's the numerator. The denominator is always double the a value, 2 times 2. So we've got a 2 times, I don't know which is better, to try and write my 2's like this or have them look like a's. Alright, so what do we have here? Well, we've got this plus minus symbol, and I'm just going to write it in front. And underneath here, I have the square root. Negative times negative is positive, and I can take the square root of 4. I know that's a 2. And 2 times 5 is 10. I can't simplify the square root of 10. Hey, I'm dividing it by 4, but this 2 and those both have an even number. We can reduce this fraction. We've got plus or minus the square root of 10 divided by 2, because I can rewrite the number 4 as 2 times 2. And 2 divided by 2 is just 1, so those cancel each other out. So hopefully that's the same answer, yeah, that we have over there. So hey, I hope this helps. Request more videos and I'll make them, and I'll try to make them shorter next time, and I'll always allow you to fast forward through it anyway.